Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which checks if a given tree can be folded or not. First, let us take an example. A tree can be folded if left and right subtrees of the tree are structure-wise mirror image of each other. Here, tree A and tree B can be folded and tree C and tree D cannot be folded. Now, let us see the algorithm which will assist us in finding out if a tree can be folded or not. Let us also have a sample tree to test our algorithm. We call the isFoldable tree function with root node passed into it. So, root will point to 10. Since root is not null, we call the ifFoldable util function with root's left and right child. So now in the isFoldable util function, n1 will point to 7 and n2 will point to 15. As n1 and n2 are both not null, we check if either of them is null. Since it is false, we check if left and right subtrees are mirrors. So we call the left child of n1 and right child of n2 using a call stack. Now n1 and n2 both will point to null. Since both point to null, we return true. Now we pass the right child of n1 and left child of n2. So n1 will point to 9 and n2 will point to 11. Since n1 and n2 are not null, we pass the left child of n1 and right child of n2. As both n1 and n2 are leaf node, we pass null to n1 and n2. As both are pointing to null, we return true. Next, we pass the right child of n1 and left child of n2, which are again null. Again, since both are pointing to null, we return true. True ANDed with true will return true. So we return true to isFoldable function. The isFoldable function will in turn return true to the main function, and hence this is a foldable binary tree. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in a binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.